Okay, in this problem, I want to find the mass moment of inertia about the centroidal axis, basically an axis about g for this pendulum that's got a rod and a thin plate attached to it. Okay, I know some things. The first thing I need to do is I need to find where g is located. I need to find the location of the centroid. So I've got to go back using my centroid equation, which is going to be the sum of all of, break it up into pieces, find the centroid of each piece times its area over the total area, right? So what I'll do here is I'll have my rod 1 and my plate 2. Okay, so the center of the rod is going to be 1/2 of 2, so it's just 1 from, again, point O, okay, times, and this should not be area, these should be mass. I apologize for that. Throw that in there, okay? And the mass of the rod is 3, okay, plus what's going on with the plate, which is 2.25 away. The center of that plate, right, is 2.25 from O, okay? And its mass is 5, okay? And I divide that by the total mass, which is going to be 3 plus 5, and I find that that moment of inertia is 1.78 meters from point O. That's what y bar equals. Now, again, I need that because that's where I want to find the moment of inertia of the entire thing about. So I'm going to break it up into um, pieces, find the moment of inertia of each piece about point G there, okay, which I use my centroidal moment of inertia plus the mass times the distance away squared. Okay, so for a rod, I go look that up in the back of the book. About the center of a rod, the moment of inertia is 1/12 ml squared, where m is 3 for this rod and l is 2. 1/12 ml squared. Plus the mass of this rod, which is 3, times the distance away. And again, that is going to be the 1.78 minus 1, right? Because the center of that rod is at 1. This is the D that I'm looking for right here. So it's going to be 1.78 minus that 1, all of that squared. So the moment of inertia of that rod about point G is 2.83 times kilogram meters squared. So similarly for the plate, I'm going to take the centroidal moment of inertia that I look up in the back of the book. So about the center of a plate, that is 1/12 mass, which is 5, times the length of each side squared, and then added together. So that'll be 1 squared plus 0.5 squared. Okay. So that's the moment of inertia about the center of that plate. Okay. Of course, then I need to do parallel axis theorem. So the mass of that plate is 5, and then it's going to be 2.25 minus the 1.78, that whole thing squared. Because again, the center of that plate is right there. I'm looking for this distance right here, right? So the center of the plate is 2.25 from O. The um, point G is 1.78 from point O. So the difference between them is the distance between the two axes of interest there. And I get the moment of inertia of this one of 1.62 kilogram meters squared. Okay. Now all I do is add those two together. Find the total moment of inertia. I just add 2.83 plus 1.62, and I get 4.45, and that'll be kilogram meters squared, like so. Okay, so again, just like we did with areas, you just break it up into pieces, use parallel axis theorem to find the moment of inertia of um, each component about the axis of interest, and then add them together.